back to our channel and back to the tutorial for deep learning. Today I'm going to continue topic called very deep convolutional network, VGG net. We can say shortly is one of the convolutional network need for computer vision. That means you want to think about object everything, you can go with this one. Today only just basics. Later we go for implementations, and we are going to say about only VGG16. So today let's see what is VGC and why we need, and the architecture of VGC16, at last some general steps for implementing VGC16 also. So what is VGC? Let's go for this one. The abbreviation called Visual Geometry Group. So it's a standard D convolution architecture. Moreover, the term here D refers to the number of layers with VGC16 or VGC19 also. Moreover, it's one of the developed deep neural network, and moreover, what you can say, still one of the successful and popular image recognition architecture. This is one VGG. So later we go for some other versions. So what is VGG? So why we need? Yeah, what is VGG? Just not why we need this VGG, because it's one of the familiar models just I told you, also known as convert. Moreover, it's a type of CNN, and here just now told you it's also a variety of CNN, where one of the best computer vision models today, and also one of the familiar object detection and classification algorithm, which can be able to classify 1000 images of 1000 different categories with 92.7% accuracy, and also one of the familiar algorithm for image classification and easier to use with transfer learning. This because the previous session I explained about the transfer learning. So this is the architecture, general architecture of the VGC16, where consists of a matrix format like 224 multiplies 224 multiplies 3. Again same, and another layer consists of 112 and multiplies 112 and 128 and so on. Either you have like this you have. So what are the layers are important here means generally VGG16 consists of convolution plus reload, then max pooling, then followed by fully connected plus reload, at last softmax. So these are the picture. Let's go for some other explanation also. So this is the input 1, where consists of a convolution 1 to pooling followed by 2 to pooling, and output dense like that. So now architecture. So as you know, input here, the input is what? Generally the net receives 224 multiplies 224 image input. Moreover, convolutions is here the convolution method of VGG is the smallest possible receptive filter 3 multiples 3, and also apart from this is uses 1 multiplies 1 convolution filter. Everything will go forward when I go for implementation and real activation. So it's the one of the common one, where also collection major innovation for reducing training time. Moreover, the function provides matching output for positive inputs and output 0 for negative inputs also. And also, as I told you, this one has a set convolution state of 1 pixel to preserve the spatial resolution after convolution generally. This one hidden layer. So generally CNN we have hidden layers. Here also we have hidden layers. So one of the specialty of this one here, the VGG networks hidden layers use reload instead of local response normalization like Alexander. Here OU means need, it increases training time and memory consumption with little improvement to overall accuracy. On pooling layers, when you come to the point of pooling layer, what you can understand, the pooling layer always follows several convolution layers, but and also same time it helps to reduce dimensionality and the number of parameters of the future maps created by each convolution type. And also here the pooling generally go for reduce the dimensionality of the data, just I told you, and also have available filters from 64 to 128, 256, and eventually 512 in the final layers. Fully connected layer. When you come to the point of fully connected layers, here it consists of 3 fully connected layers. The first 2 layers have 4096 channels, and the third layer consists of 1000 channels by default. So it's suppose if you have data set and you want to implement, what you can do? You can go with Keras, TensorFlow, and so on and so on. Even you can combine with transfer learning. So there will be a few steps there. If you go with Keras, first step saying like import the library for VGG16, then create an object for training and testing, initialize the model, followed by pass the data to the dense layer, compile the model, import library to monitor and control training. Another step saying visualize the training and validation data. At last, test your model that means prediction. Let's assume they give a dark data set, dark or cat. What you can do? Just now I told you 92 point minimum guarantee of getting the accuracy in this VGC16. So if you want to predict whether is an input, you can take data set or else if you want to differentiate and find out which is dark and which is cat. So that time you can go for this procedure. Once go for prediction, suppose you are giving cat as an input image, at last it will say the input image cat, and prediction it will say the like this only. Prediction it will say 92.7 accuracy and so on. So this is about a general introduction and a simple way what you can understand about the VGG16. Remaining, we will see. If you like the video, please subscribe and share with friends. Thank you.